Hi students, this is AJ sir. Let's study 9th standard ICSE Math, Chapter 23, Exercises A and B, Trigonometrical Ratios of Standard Angles. A very easy chapter. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information. Before you start solving these two exercises, you must learn this table by heart. You should know all these values at your fingertips. I don't want you to go back and forth to look at these table values again and again while solving these sums. If you learn this by heart, it will save your time. Let's start with 23A. Cancel question 1 entirely. They are very easy sums. Cancel 2.1 as well. Let's start with 2.2. Find the value of this expression. So these are all standard angles. Tan 45 is 1. Cosec 30 is 2. Sec 60 is 2. Cot 45 is 1 minus 5 into sin 90. So sin 90 is 1. So 5 into 1 is 5. Upon 2 into cos 0, and cos 0 is again 1, so 2 into 1 is again 2. Now these are fractions. Do the LCM and get the answer. Next, 3.2. It's a proving sum, so we'll start with LHS and we'll get the answer as 0, which is the RHS. So copy the LHS. Cos 30 value into dot means multiplication. Cos 60 value minus sin 30, sin 60. Do not just copy from here. Try to remember the values and substitute it on your own. This will train you to think of these values very quickly in the exams and save your precious time. And then it's a normal algebra. No need for LCM. Denominators are the same. Answer is 0, which is the RHS. Hence proved. 3.4. Prove that this is equal to cos 60. So we start with LHS. Cos square 30 minus sin square 30. By the way, this is one formula, remember? Cos square theta minus sin square theta is equal to... No, it's not a formula. That was cos square theta plus sin square theta, which was equal to 1. Anyway, we substitute the values of cos theta. There's a square, so of course you have to square the whole value. Even here, square the whole value, get the answers, subtract it. Answer is half, which is indeed cos 60, because cos 60 is half if you look at the table. And that is the RHS, hence proved. 3.6. Prove that this is equal to 0. So we start with LHS, we substitute the values, we solve them, and we get the RHS. Now, you need to actually solve it, show more steps if required. Do the calculation on your own, don't just copy, because it may seem easy, but we make silly mistakes without practice. Also, the remaining sums, which will be for homework, you need to solve them without looking at the table. You need to remember all the values first, learn it first, and at the end, make sure you check the answer. Now, we know that the RHS is 0. Doesn't mean that you just directly jump to 0, like I have. You have to show the step of calculation. It's possible you made a silly mistake here. Such manipulation would not help you to gain marks. You will lose all the marks if you don't show the steps properly. Cancel 4.1, again very easy. 4.2, prove that this is equal to that. So cos of 2 into 30, that's cos of 60, right? So substitute the value of cos 60, that is half, which is the LHS. Now solve the RHS separately. You could even have done it on the right hand side. So we substitute the values of tan 30 and square it, tan 30 in the denominator as well and square it. Take the LCM. And how do we solve this? Well, one way to do it, just cancel 3 and 3. So that becomes 2 upon 4, that becomes half. You can even do 2 upon 3 into 3 upon 4. That is right. When you do division, when you convert it into multiplication, you take the reciprocal of the denominator entirely. So half half. So LHS is equal to RHS. Mention this step in the end. Next, in question 5, cancel Roman number 1. It's very easy. I'm reducing your homework. 5.2, mark it as IMP. They want the answer of cos 45. Now from the table we already know that the answer of cos 45 is 1 upon root 2, but they want us to solve and find it. So first of all, let's find out if there is any 45-degree angle in this triangle. Clearly it's a right angled isosceles triangle, so using angle sum property we can prove that angle C as well as angle A is 45 degrees. So now the question is, how much is cos of angle C? That's adjacent upon hypotenuse. Adjacent, that is BC, we have taken as x in the question. So we'll use Pythagoras theorem to find the value of AC, which is going to be root 2x. And then we can find the ratio. Here are the steps. So first of all, we assume the angles to be y. Don't use x because x is already used in the question. Then using angle sum property, we prove that y is 45. That means angle A as well as angle C are both 45 degrees each. Then we use Pythagoras theorem to find the value of AC, which comes out to be root 2x. And then we start with Roman number 2. So when you do Roman number 3, no need to show all the previous steps again. You can do it immediately after this sum because there is a continuity in this sum. So cos 45 is cos angle C, which you could have even written as cos of angle A, which is BC upon AC, that is x upon root 2x, x cut 1 upon root 2. Just cross check. Is it truly the value of cos 45? Yes, it is. That means your sum is right. 6.2, mark it as IMP. So we've got LHS. We have to prove it equal to 2. Method is same. Just substitute the value of sine of 30. Sine of 30 is 1 upon 2. There's a fourth power. So fourth power of 1 upon 2. Similarly, 1 upon 2 raised to 4 here. 1 upon root 2 squared minus 1 squared. Just substitute all the values. Now this is a normal algebra sum. It's like a fractions chapter. You take the LCM wherever required, use a BODMAS rule and get the final answer. Make sure you practice these solving of fractions with BODMAS rule to check whether you are perfect with it or are you still making some silly mistakes about the plus and minus signs. Now 7.2, if sec A is equal to cosec A, what is the value of A? Well, if you look at the table itself, I can see that sec and cosec have the same value, root 2, when the angle is 45 degrees. So you should know beforehand that the answer is going to be 45 degrees, but you can't write the answer directly. You have to solve it. So sec A is equal to cosec A. So first of all, convert them into the elementary forms, the basic sine cos form, the reciprocal form, that is 1 upon cos A. This is 1 upon sine A. Sine A goes up. That becomes sine A upon cos A is equal to 1. Sine A upon cos A is tan A, and tan A is equal to 1. Now what angle of tan is equal to 1? That is, tan of which angle is 1? Tan of 45 is 1, if you remember the table values. That means angle A is indeed 45. Now if you look at 7.4, they are saying sine x is equal to cos y. What's the relationship between x and y? Assuming that both the angles are acute. Because sometimes angles can be obtuse. So how much is sine of 120 or cos of 150? That is outside the scope of this chapter. So if sine x is equal to cos y, let's convert this cos into a sine first. How do we do that? Complementary angles. It will be 90 minus y. That means by comparing this angle and this angle is the same. No, it's not like sine cancelled, it's just comparing. So x is equal to 90 minus y, and that's how we get the relationship x plus y is equal to 90. That means they are complementary angles, which makes sense. Even if you look at the table, the values of sine and cos are in reverse order thanks to the complementary nature. And tan values are simply sine upon cos. Cot is a reciprocal of tan. Yep, 1 upon 0 is infinity, right? And imagining infinity is insanity, so not defined. Sec is a reciprocal of cos, and cosec is a reciprocal of sine. So basically, if you remember the values of sine, you have literally remembered the values of all other ratios. Everything can be derived from the sine values here. That's the trick. Sorry, what's your question? How to remember the sine values? Oh, it's so difficult to remember 5 values, right? You would rather have a chip, a ready-made chip inserted in your brain with all the memories stored in it. You don't want to take the effort to learn something. So sad. Next question is 8.2. If this is equal to this, is it true or false? Okay, we'll have to solve this. Let's start with LHS. Convert this into cos, convert this into sine and cos. Cos and cos cancelled. That's right, cos theta and cos theta cancelled. So what is left is 1 upon sine, which is cosec. So that is equal to RHS. So it's true. 9.2. Does the value of cos theta increase or decrease as theta increases? Let's look at the table and decide. So as the value of the angles is increasing, what's happening to the value of cos? It's, I guess, decreasing, because this is the biggest value 1 and this is 0, and it's subsequently decreasing. If you actually calculate this, 1.732 upon 2 or 1 upon 1.414 and 1 upon 2 is 0.5, you will agree that the value is decreasing. So the answer is decreases. Yep, you just have to write that much. Next, 10.2, find the value of 2 upon tan 30, but here the value of root 3 is given, and even if it weren't, we knew the value is 1.732. So substitute that value and get the answer. But they even said that get the answer in up to 2 decimal places, correct to 2 decimal places. So round off, ignore the 4 in the end. It's a small number, less than 5, so the previous number won't increase. So the answer is 3.46. This is the approximate sign. And finally, 11.2, it's an IMP sum. Finally something challenging. So we have to solve this where the value of b is 20. Value of b is 20. So what is 3 into 20? It's 60. Okay. 2 into 20 is 40. 40 plus 5 is 45. So that's 45. 3 into b, so 3 into 20 is 60. Fine. And this is b, again 40 minus 10 is 30. So we've changed the question to this format. Now 3 into sine 60. Sine 60 value we know, root 3 upon 2. Cos 45 value, cos 60 value, and sine 30 value. So now it's a fraction sum. In the numerator, we'll have to find the LCM, which would be easy. We just have to rationalize the denominator here, into root 2, so the denominator becomes 2. So the denominator becomes same. The denominator is just 1 upon root 2 here, this one. So now this becomes root 3 plus 2 root 2 the whole upon 2. And what about this denominator? Well, we'll convert this into a multiplication with the reciprocal. So 1 upon 2 becomes 2 upon 1. 2 and 2 cancelled, and this is the final answer. Next, in 23b, 1.2. The logic is the same here. We start with LHS. A's value is given as 60 and B's value is given as 30. So A plus B is 90 and cos 90 is 0. So that's the LHS value. Similarly, RHS, substitute the values of A and B and substitute the trigonometrical ratios and solve it. Again, here the answer is 0. So LHS is equal to RHS, proved. Similarly, in Roman number 4, we have to prove this is equal to this. Substitute the values of A and B. That is 60 minus 30 is 30. Tan 30's value is given. Similarly for RHS, substitute the values and solve ahead. Remember, here it will be into root 3 upon root 3. So this becomes 3 minus 1 upon root 3. Here this gets cancelled, so that's upon 2. And 2 and 2 gets cancelled, so the answer is 1 upon root 3. No need to rationalize the denominator here because this is a proving sum. We don't have to evaluate and find the final answer. We just have to prove that this is also 1 upon root 3 and this is also 1 upon root 3. So LHS is equal to RHS. Next, 2.2, mark it as IMP. Now there are 3 parts here. LHS, this is the RHS, and what do we call this? Can we call it MHS? No, I'm going to call this RHS1 and RHS2, or if you don't just label it, it's okay. But the method is same. For LHS, substitute the value of A as 30, that becomes 2 into 30, 60, cos 60 is half. Similarly, find the value of cos square A minus sin square A by substituting the values and solving. Also find the value of 1 minus tan square a upon 1 plus tan square by substituting values here, and then finally we get half. So hence proved that the three expressions are equal. Cancel 2.3 and 2.4, they are very easy. Cancel 4.1 and 4.2 also, they are very easy. 3.2, let's prove that. A's value is given as 45 and even B's value is 45. Now this is same as sum number question 1.3, but here the values of A and B were different. Sorry, 1.2, the values of A and B are different. So is it true that this is a universal formula, an actual trigonometry equation? Well, you don't have to deal with this in 9th standard. We just have to substitute the values and get the answers. So cos of 90 is 0, RHS substitute and get the values 0, LHS is equal to RHS, proved. Similarly 4.4, we have to prove this is equal to this, but here the value of A is given as 30, so 2A will be 60, so substitute the values. Be careful while solving. When division becomes multiplication, do the reciprocal of this denominator, cut 1 upon root 3. Similarly RHS is 1 upon root 3, LHS is equal to RHS. And finally 4.7 sum is marked as IMP. We start with the LHS here. Remember, there is a cube here and this is coefficient 3. This is not a cube, so be careful, don't make a silly mistake. Substitute the value of A, that is 30, and here 3 into 30 will be 90. Similarly, substitute all the angle values, substitute the trigonometrical ratios. This is a cube out here, even here there is a cube. So this becomes 3 root 3 upon 8 upon root 3 upon 2. So root 3 and root 3 gets cancelled. 2 1s are, 2 4s are. So finally what is left is 3 upon 4. Do the calculations yourself, don't copy. And even here find the LCM and divide with this fraction. You get this answer. Answer finally, they come together to become 12 upon 4. 12 upon 4 is 3, which is the RHS, hence proved.